Hey y'all, welcome back. We will go ahead and look at the homework problems from yesterday. I'll go over first two for you. Students, just check your work as I go over these two, and once finished, you will be working on the problems on the back. So first question was, an object is projected horizontally at 8 meters per second from the top of 122.5 meters cliff. How far from the base of the cliff will the object strike? So when you're looking at this question, students, first thing you need to see is draw the diagram. So that's my cliff. As long as you draw it correctly, it doesn't matter. Some students make it really beautiful. That's up to you. Remember, we are projecting it horizontally, but it's not going to go straight because gravity will pull it down. And that's why it's 2D motion. It will be parabola in curve. The trajectory, which is the path, will be parabola in shape. Okay. Now let's put the numbers from the question. So x velocity is given to me as 8 meters per second. That's Vx. The height of the cliff is, this height is 122.5 meters. So that's my negative 122.5. The reason I'm putting negative here because a ball is going down, or the object is going down. Now acceleration is y is just like a free fall. It's negative 9.8 meters per second square. And remember, we are not giving any initial velocity in y. I only gave it x velocity. So this would be 0. It's just like a free fall, 0 meters per second. Now, question is asking how far. So this is the distance, which is a question in front of us from the base. This is the base of the cliff. How far the ball will be at the end. That's what I'm looking. I'm looking for x distance. I need to have time in order to do that. I don't have enough information in x, so I might solve that on y. When I'm using my equation from the equation sheet, I will be looking at any of these equations. I will look at time equation over here and work on it. So time is, I'll be solving over here. T equals square root of 2 dy. It's delta y over g. Delta y is nothing but the y distance. Now let's plug those values in. 2 times negative 122.5. 122.5 divided by negative 9.8, and we know that negatives will cancel and become positive. You do not want to put negative inside the radical because negative inside the radical will give you incorrect answer. If you solve it, time comes out to be square root of 25, which is 5 seconds. Remember, time it took to go down is same as time it takes to go forward. That means this 5 second can be used here. Now the equation for my x side is over velocity equation. Velocity is displacement over time. It's also written as delta x. If I'm looking for in the projectile segment of the equation sheet, delta x is vx times t. So when you manipulate this equation, distance in x is same as delta x, which is also known as delta x, is vx times t. So x velocity is how much? 8 times 5, which is 40 meters. Done. So did I solve for everything? I believe yes. That's my answer for x distance, and that's the time. Did we got both? Yes. So you can see time is the variable which connects both x and y motion, or else they are working independently. When you're solving this, you don't have to worry about this. When you're solving this, you don't have to worry about this. Now let's look at the next problem, folks. A stone is thrown horizontally from the top of a cliff which is 40 meters high. It lands 50 meters from the cliff's base. How long does the stone take to reach the bottom of the cliff? How fast was the stone traveling when it left the cliff? Sketch the trajectory of the stone. So if I'm sketching the trajectory, the diagram would be pretty similar to what I had earlier. The stone is also projected horizontally. That's its x velocity. It is pulled down, so trajectory is parabola. So if I'm solving this, it's blurry, so let me fix that a little bit before I proceed. Okay. Let's look at all the knowns and unknowns. So question gives us the height, which is 40 meters. So that's 40 meters. And the x distance, which is 50 meters. Often students switch them to, and that's when their answers are wrong. Because it lands 50 meters from the base of the cliff, that's my x distance, so that's 50 meters. X velocity is, and this would be 40 meters. And remember, it's negative because stone is going down on the y side. Now we know acceleration is going to be negative 9.8. That's my y acceleration. Initial velocity would be 0. These are the two things you can always fill in with when you start. So I'm looking for how long does this stone take. So I'm looking for time. I'm also looking for x velocity because how fast was the stone moving when it was launched. That's the question, x velocity. So let's solve for time using the same equation. T equals square root of 2 delta y over g. Let's plug in the numbers. 2 times negative 40 divided by g, which is negative 9.8. When you solve this for time, you happen to get, I believe it comes out to be 2.86 seconds. Remember, it's 2.85 and numbers after that. Don't worry, don't overthink on rounding. That's not the case in physics, but make sure you round correctly, but you won't lose points because you rounded it incorrectly. Because if someone wrote 2.85, I'm not going to take their points off because students ask about that a lot. Anyway, I will be using same time over here, 2.86 seconds. Now Vx equals dx times t. Sorry, dx divided by t, my bad. So it's going to be 50 divided by 2.86. That gives me answer as 17.48 meters per second. Don't forget to put a box around your answers. And we are done with the first two problems. I'll let you watch this. Students, we will go ahead and look at what else we are supposed to do. So first thing, you will be completing the problems on the back. I'll be sharing these answers sometimes tomorrow. Okay, so try these two if you haven't done so already. If you did it and now you figured out where you're making mistakes, double check your work. After this, today you will be in today's lesson, so I'll go to today's lesson and show you what else you need to do. So once you get to the lesson, you will launch the slide with the conceptual questions. Go over these slides. It's not just the question, there's a lot of information in there. Everything we have done at some point in class. Once you get to the last slide, let me launch it and see. Yeah. So when you get to the last slide, here, NAL check-in. Complete any one of the quadrants and submit in the Dropbox. You are not doing all four. That will be too much for you. Today, all you're doing is picking one of the questions which you're comfortable with. And you can look at any of the works we have done in past, including problems, mind map template, notes, and try to work on this. So one of the first quadrant says, you are writing a paragraph explaining if a package is dropped off a plane, in this scenario, why the package is right under the plane. You're explaining that by writing a paragraph. That could be one thing. Or you could choose, let me go and look at more scenarios. You can pick one of the number problems. It could be one from the homework assignments we are doing. These are the problems we were doing. Pick any of these problems for copy paper, make a beautiful picture and show X solution and Y. Or you can have your own problem. It could be one from the mind map template we did earlier. You can do one of those problems. Work it out completely. Make sure you write the problem also, which one you're working. So let's say you chose number 3. Okay, chose the tiger question. Make sure you draw the full, complete, colorful diagram. Show the solution in X and Y, all the work equations. So complete work of the problem you'll be submitting. Or the other quadrant says, write any 3 2D motion high-level questions. Any high-level questions means not how much is the acceleration in Y, which is negative 9.8, but that's not high level. That's just memorization. something along the lines, maybe something like this. So if the package is dropped off a plane, it lands under it. So we had a question on that. Why is so? Why this happens? So the difficult questions you're writing, and then you are answering two of them. Not only you're writing the questions, you're answering two of those questions and submitting it. So mention in your answer which quadrant you're working with, what you're comfortable with, and the last one is write a poem which includes all the 2D motion concepts. So those who are writers, if you think you're good in that and that's your ability, try doing number 4. Just pick one which you're comfortable with, work on that, turn it in the box. The drop box is there for NAL check-in. And this is the last slide in the PowerPoint from today. Have a great day, y'all. Bye, guys.